as far as the concept of IUPAC nomenclature of alkanes, I proudly pronounce to you that we have come to the end. All you need to do is to do some practice, and then the whole concept will get better with you. Now, before I can proceed to the next part of our chemistry made simple series, let me bring to your attention some of the common examinable facts about our first concept, which has been nomenclature of alkanes. First and foremost, the most important examinable aspect is that all of us who are interested in this or who have seen this from the start should be able to name alkanes by following IUPAC rules or guidelines. That one, I want to believe that at least you have developed some level of expertise. Let me remind you that you can click the link in the description. There is our Telegram channel where there is a PDF document that is about our first part, nomenclature of alkanes. You can always refer to this document at any time of your convenience. Nonetheless, I have fetched out a few of the tricky examinable aspects about what I've been covering with you, and that is IUPAC nomenclature of alkanes. The first, I have written it here in form of a question. So what does the question state? Is that you have been given a compound. The compound is tetra 111, then tetramethylmethane. And then the question wants you to proceed and write down the condensed structure formula. Condensed structure formula of the compound. So we are going to start by writing that condensed structure formula. Now, when we are writing the structure formula of such a compound, we go back to the name of the compound, and our starting point is always the parent name of the compound. Now that means that our parent name in this case is methane. Going back to part 1, if you are an alkane with the name methane, is just having one carbon. So when we are writing our condensed structure formula from methane, we will have one carbon. So we start by writing one carbon. Please let me emphasize that this single carbon, we have derived it from the parent name methane. Now we go back and see or remind ourselves that carbon belongs to group 4A of a periodic table and has a maximum covalency of 4. For that case, therefore, carbon can form up to 4 bonds, covalent bonds to be specific. So this and this, then that one and that one. These 4 lines that I have written radiating from C indicate the 4 bonds. Why 4, I emphasize, is that carbon has a maximum covalency of 4 and therefore can form 4 covalent bonds. Now, after that, we have to go back and see is that each of these four lines must be connected to what has been indicated in the name here as methyl. So by completing our structure is that the condensed structure formula is that there is a methyl group here, another methyl, and then another methyl, and finally another methyl. So how many methyl groups have we written? 1, 2, 3, 4. These 4 correspond to the tetra. So we have written our formula or the condensed structure formula of the given compound. So now the question wants us to proceed and derive. We're supposed, by basing on we're supposed to derive its correct IUPAC name. So that means that this is a wrong name. So we go back to the basics, is that if this is the correct formula of the compound, is that we are going to number or to determine the parent chain. So from this is that you are having the following chains: 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So there are 4 chains, and each of the 4 carbon chains has 3 carbon atoms. And this implies that the parent name, our parent name, like we saw in the previous parts, the parent name is therefore propane. Then, after having identified our parent name or the parent chain for that case, we go back and number the parent chain. Let me bring to your attention that now, for simplicity, this is the parent chain that I am using. However, any other parent chain, as long as it has 3 carbon atoms from it, because we realize there are 4, will always give you the correct answer. So this is position 1, position 2, position 3, position 1, position 2, position 3. So after numbering, we go back to our chain and we are looking out for the carbon atom on the chain that is attached to the substituents. And for this case, in either direction of numbering, is that the carbon atom 2 and also the carbon atom 2. Finally, we write the name of our compound as 2, 2, because why do we write this 2? We have previously seen is that because on position 2 in either direction, there is a similar alkyl substituent. Specifically now, the alkyl substituent is a methyl group. So that's why I have 2, 2, and then a hyphen, and then the word di. The di indicates 2, and then the name of the similar alkyl substituent is methyl, and finally the parent name, which is propane. So we have been able to write the condensed structure formula, and we have also been able to write its correct IUPAC name. The last part is that we should explain our answer briefly. The explanation that the examiner in this case expects you to give is why this name is wrong as compared to this. So we shall be comparing the given name and the name that we have obtained. So a simple explanation could actually be that the given name, that is that one there, is wrong. Then we go ahead and see what could be the reason why this is incorrect or wrong. So the direct reason that I see is due to, so the person naming failed in determining the parent chain. So the person who named this compound as 1, 1, 1, 1 tetramethyl methane actually failed in determining the parent chain. So to make a recap or a brief summary of my answer is that whenever you are obtaining the condensed structure formula from the given IUPAC name, we always start, this is our starting point, start from the parent name. And from the parent name, we determine our starting point as a single carbon, because methane is an alkane that has only 1 carbon. And then from the other part, this is the second part, which we consider. The second part we consider is this. This is the second part that we consider. And from this second part, we are seeing the total number. We are seeing the total number. Tetramethyl means that there are actually 4. So you see on this carbon atom, we have 1, 2, 3, 4. And at that point, you have finished writing the name. Our second examination consideration now is also what I have written here. We first read through is that we are supposed to determine the correctness of the name. So this implies that the given name is incorrect. So it is our work, or it is our task, to first determine the correctness of the name. So how do we determine the correctness? By going back to the name and seeing if the rules of IUPAC nomenclature of alkanes were followed in each case. So if we inspect the name is 5-methyl, 3,3 diethyl, 5-cyclopropyl heptane. So that is what we are having. Now, a quick analysis of this shows me that the name was wrong, or is therefore wrong, because we did not follow the alphabetical arrangement of the groups. So if we are to get the correct name the correct name is therefore going to be, the first group therefore is this which starts with C, not this which starts with M. Since C is the most alphabetically superior letter that we have, so the correct name should have started with 5 and then cyclopropyl, then followed by this and this. Definitely this follows, and finally this is the last substituent, followed by the parent name. In this case, the parent name remains the way it is. Now, after depending on our findings, these are the findings, we're supposed to write the condensed structure formula of this compound. Like we did in the examinable aspect number 1, is that when we are writing the condensed structure formula for this compound, we start with the parent name, considering the parent name, which is heptane. And being heptane, it means that on this compound, we have a 7 carbon chain structure. 1, 2, 3, 4, 5, 6, 7. So that is what we are having. These 7 carbon atoms, we have written them by basing on heptane. Now, choose any side of this chain. We could decide to start from there, or someone could also start from there, and then start allocating these positions. Now, without wasting time, if I am to start from this side, this is position 1, position 2, position 3. On position 3, we have 2 ethyl groups. So this gives us that one there. So this is position 3. Then the next is position 4, position 5. On position 5, we also have 2 groups. One is a methyl group, and the other is a cyclopropyl group. So that is what we have. Now the remaining parts of this must be filled in with hydrogen atoms, but by bearing in mind that carbon has a maximum valence of 4 and therefore must form 4 covalent bonds. So this first carbon here already has 2 bonds, and therefore we add 2 more to make them 4. And on each of these we put a hydrogen. This already has 2, and so we are adding. Then this one already has 4. 1, 2, 3, 4. Nothing to add. And then the same applies to that one, which is now 1, 2, 3, 4. This already has 1, 2, 3, 4. Nothing to add. Then this has 1, 2. This is 3. This is the 4th. Finally, this one and that one. Now, what we have written here is not the condensed structure formula. It is actually the open structure formula. But the question wants us to write the condensed structure formula. So from this, we can obtain the condensed structure formula CH3, first carbon, second carbon, third carbon has 2 groups, next carbon, the next carbon, this one just has 2, then the next, it has a methyl group, and a cyclopropyl group, as simple as that. Our final consideration under examinable aspects under IUPAC nomenclature of alkanes is the question that is here, is number 3, is that we are required to name that compound correctly by basing upon the rules of IUPAC nomenclature of alkanes. Now, it is direct, but there is one mistake that we could make. So first things first, the parent name, we identify our parent chain so that we can get the parent name. So what is the parent name? The following chains are there: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3. So 6 is the highest number of carbon atoms in the chains, and therefore the parent name in this case is going to be hexane. However, let me bring to your attention that there are 2 equal chains. The tricky part of this question is in the fact that there are 2 equal carbon chains. I will show you the carbon chains. One is this. That is coming like that. But then we also have another carbon chain that I have indicated in red. So those 2 carbon chains both have an equal number of carbon atoms, and that is 6. So each of them could literally be taken as the parent chain, giving us the parent name hexane. Now the question is, which of these 2 chains, I mean the one in red and the one in blue, are you going to use? So the answer is that in such a scenario, in case there are 2 or even more than 2 possible parent chains, examine all the chains, and then the one that will be considered is the chain that has the highest number of alkyl substituents, or in simple terms, the chain that has the highest number of branches is the one that is considered. And in this case, if you took the red chain, the one I've circled in red, then you'll have only one substituent. This substituent, which we call isopropyl or secondary propyl. However, if you take the blue chain, the one I've written in blue, if you take the chain that is circled in blue ink, then you'll have 2 substituents. So therefore, the chain that we are going to use is the one that is in blue. So after identifying that, we proceed and we number our chain. So the numbering is as follows: is that this is carbon atom number 1, this is number 2, this is number 3, this is number 4, number 5, 6. Then 1, 2, 3, 4, 5, 6. So like we have seen previously, is that we go back to position 2 and also position 3. For those who are numbering going that side, then from that side to this side, we have position 4 and position 5. Computing the sum of 2 and 3 gives you 5, and the sum of 4 and 5 gives you 9. Therefore, the conclusion is that the number pairs that will be used are those ones, and we can now write our name by basing on the alphabetical superiority of the 2 alkyl substituents. So the correct name is 3, and then so to conclude this examinable aspect is that it is possible for examination considerations that you could have a compound that has more than one parent chain. And when we say more than one parent chain, we mean that they are equal chains. And in this case, the chain that will be considered in naming the compound is therefore the chain which is having the highest number of alkyl substituents. I therefore thank you once again for being part of this experience. I would like to insist that the next parts of nomenclature, IUPAC nomenclature of organic compounds, or for that case, compounds of carbon, largely depend upon our mastering of the concepts in these first parts, that is IUPAC nomenclature of alkanes. I beg you and request you to humbly go through all the videos thoroughly, and also go and do further reading in the books and the work that I have posted in our Telegram channel. Then the next parts after this are going to be workable, or will be very simple. Are going to be a simple dish for each one of you. Well, do you have a question about nomenclature of alkanes? Do you have a concept about nomenclature of alkanes? Do you have a specific challenge in the nomenclature of alkanes? Get to me, contact me by sending me an email, by using the email in the description of the video, and I will happily connect with you. Thank you once again. I wish you all the best as per learning and naming of alkanes is concerned. Until the next topic, bye for now.